Today we are jumping into section 2.3, the last section of Unit 2. The title of this section is Inverse Functions. So let's start out here with reading number 1. Describe the difference between the points of a function f of x and the points of its inverse, f inverse of x. Now many times, speaking notation, many times students, when they see this notation right here, the way they read it is f to the negative 1 power. And I just wanted to put a big exclamation points here as a warning as to not to do that, okay? Don't read it that way. The way you read this notation is f inverse of x. I do understand that that negative 1 is written in the top right hand corner, which usually is designated for exponents, but it's not an exponent in this case. All right, it's the function notation for inverse. So what is the difference between the points of a function? Let's pause here a second. Okay, back to our lesson. The difference between the points sitting on an f of x function and the points sitting on the inverse of the f of x function are the following. The difference is that the domain and range values are going to be switched. So what exactly does that mean? What it means is, for instance, let's say you have a point on the f of x function that has coordinates 2, 3. Well, that just means that the interchange coordinates 3, 2 will exist on the f inverse x function, okay? So literally all that's happening is that the function f of x will have coordinate points that are going to be switched when they are graphed on the inverse function. Why is that happening? Well, here's why. Part 2 addresses that. The graph of a function that is reflected over the y equals x line, that ends up being your inverse function. Okay? Now where exactly is the y equals x line? So if we look back into our Algebra 1 skills, we look at this equation and we notice that the coefficient of x is a 1, so that's our slope, because you know the slope-intercept equation is y equals mx plus b. Our y-intercept, which will be the plus b area, there aren't any numbers that are adding or subtracting to our x term, so it's a 0. So if we were to plot this on a quick sketch on a grid, here's our y-intercept, we would go up 1 over 1, and this is our y equals x line. So anytime we have a graph of f of x graphed on a grid, and I ask you to find the f inverse, what you're doing is you're reflecting over this y equals x line. That causes your domain and your range values to interchange or switch. So let's look at what that does to our tables. Okay, let's look at tables. So our first visual we're going to have, let's look at number 3. So here are the points displayed for our x and f of x, x comma f of x function. So these are the x and y coordinates of 4 different points sitting on this graph. Recall that I've always told you guys that f of x is our range value, okay? This is our range, in this case, if you want to think of it as our y value, okay? Now, because we are switching our x's and y's to find the points of our inverse, we switch those values, so all our y values become our x's, and all our x values become our y values of the inverse relation. Okay? So our job here is to answer this question: is the inverse, this is the inverse graph, is it a function? Well, what you notice is that it's not going to be a function because the x value 15 has been assigned two y values that are distinct, negative 3 and 3. Therefore, the answer is a no. Let's look at number 5. Again, write your x's down, which are your former y values, and write the y values of your inverse function, which are your former x's. Is this a depiction of a function? This inverse is not going to be a function because of the repeated x values here. They all have been assigned several y values. So is the inverse a function? In this case, it's not. I'm going to leave these here for your own practice. We move down. Functions the points can be displayed in relation form, list form. So the F inverse of this relation, notice that you are doing the same thing as you did with the tables, and that's just merely flipping your x and your y. Okay. You will look just like you did in Unit 1 to see if it's a function. Well, we look at our x values and there's no repetition going on. So in this case, our inverse, F inverse x, is a function. I'm going to have you do number 9 now. I want you to pause, do number 9, and then check your answers when you unpause. Okay, so you should have written -3, 1, -3, 6, 1, 5, and 5, 8. And in writing that, you would have noticed that -3 has been assigned a 1 and a 6 as its y value. Therefore, this relation is not an inverse function. It's the function of this, but it's not an inverse function. Okay, so let's move on to seeing how you can find graphs of inverses given a graph. So you've seen tables, you've seen relations, now let's work on graphs. So let's zoom in here a little bit. Let's zoom in to make this a little bit easier to see. There we go. All right, so let's look at the points of the given graph on number 11. Okay, let's name this graph h of x, okay? So h of x. I'm going to call it the h of x graph, and I'm going to give you the points of the h of x graph. So here, starting at the origin, we're going to the left 3, and we count up 6. Start at the origin. This dot just told us to go to the right 1. We didn't go up or down, so it's just 1, 0. And then this dot, we had to go to the right 3 and down 3. So we write 3, -3. So in order to graph the inverse, we would have to do h inverse x. We would interchange the values once again, just like we did on the front side of this worksheet. 6, -3, 0, 1, -3, and 3. So let's go graph those points. 1, 2, 3, 4, 5, 6, down 3, 0, up 1, -3, up 3. Once you've plotted those points, we will get a straight edge and connect those dots to see the inverse of our given graph. I'm going to highlight it so that it jumps out, so that we can see the difference between the given h of x graph and the resulting h inverse graph. Okay. And so me highlighting it here gives you a sort of key to understand which one is which. Now, how did that happen? Again, just a reminder, you just finished reflecting over the y equals x graph. So the y equals x graph has a slope of 1, so we make sure we angle off this ruler good enough. I'm going to draw the y equals x line here in this bright pink color so that you can understand that you just reflected your h of x graph over the y equals x pink line, and the result was the yellow line. Okay, so I want you to do the same thing. I want you to come down here to number 11. I'm going to let you do the 4 over here on the right on your own, but I want you to do number 14 on your own. I want you to go ahead and reflect that graph over again. Let me find the y equals x line here. That oval, if it reflected over this line, where would you end up graphing it? Okay, so let's call this oval graph, let's call it the g of x graph. Okay, so go find your points and pause the video so that you can work this problem out. All right, so you're back. So the points you should have come up with were -6, -1 of the original function. Okay, we're looking at g of x. We're calling that the g of x function. -9, 3, -6, 7, and -3, 3. When you switched those around, oops, I guess I need to title this as g inverse of x. Okay. You ended up with the points. Oh, I'm going to have to really run down here. Hope you can still see me. Let's see, let's shift this paper up a little bit. -1, -6, 3, -9. I'm going to come over here. 7, -6, and 3, -3. So let's plot those. So -1, 1, 2, 3, 4, 5, 6. 1, 2, 3 for +3, and then 9. So I know that's 6. So 7, 8, 9. And then 7, -6. 1, 2, 3, 4, 5, 6, 7. -6. Since I've done that one before already. And then 3, -3. 1, 2, 3. 1, 2, 3. So I can see my oval shape. See if I can draw an oval at a good angle here. I'm trying. Let me twist my paper a little bit. There we go. It's the best I can do. Alright, so here's the oval that was reflected over the y equals x line. So let me do my little, you know what, let's do purple since we did yellow before. So this function now became this function. Okay. And if you notice, if you were to fold your paper right over that y equals x line, I know it's kind of hard to show, but do you see how, let's try here, you see how they overlap on one another? See that? That's what's happening. Okay, so that imprints on the other side. Alrighty? Okay, now let's move on to what will you do when you are required to find the inverse of an equation. You have figured out how to find the inverse of a table, of a relation, of a graph, but what about an equation given to you, as in problems 17 through 22? So there are 4 steps I will need you to follow in order to get this task done. So let's write out the steps so that you have them as references until you have mastered this skill, okay? So we don't have much room, so we're going to kind of cramp it up in here. So step number one, the first thing I want you to do is, can you even see what I'm writing? Identify your x and your y variable, okay? Then number 2, you are going to interchange the x and y and then rewrite that equation. That's a slash here, by the way, okay? Step number 3, you are going to solve for the new y, okay? And then last, number 4, revert back to your function notation. And I'll explain to you what I mean by that in all these examples. Okay, so let's find the inverse. We are going to start off with number 17. Identify your x and your y variable. Well, my x is right here, and hopefully by now you remember now that the function notation f of x is the representation of all the y values in your f of x graph. Okay, so we don't write y equals anymore. We're trying to grow up and use function notation, but this is your y, okay? So we're going to identify the x and the y, and so we know this is a y, this is x, but we have to interchange it. So my f of x becomes x, my 2x becomes 2y minus 7. So this is you switching it around. Then you rewrote it, that's that, and you're going to solve for the new y. So I'm solving for this new y. Okay, this is y solved for here, but now this is my new y, because this is going to become my inverse function that I'm looking for. So I need this isolated, so I need to add 7 on both sides to start solving. Ugh, that is not a straight line. That's going to bother me. I know I have an issue. Let's try that again. Is that a little bit better? A little bit better. Almost do the same thing. Okay, x plus 7. Those stay apart because they're not like terms. The 2y comes down, and the negative 7 and plus 7 is 0. Now what do we need to do? Get rid of that 2. It's multiplying with the y. Undo it by dividing both sides by 2. Those become 1. So our y is now isolated for step 3. We are done. All we need to do is revert to writing our function notation answer for the inverse of f of x. So f inverse of x, I mention what my function is, and then I say, hey, this is my answer for my inverse. If this was g of x, you'd say g inverse of x. If this was h of x, you'll say h inverse of x. Write down the answer for what you got for y. And so in this case, you guys can write it like this, or if you prefer breaking up into 2 fractions, you can write it like that. Either one works, because this x has a coefficient of 1, so 1 over 2x is this part, 7 divided by 2 is 7/2. So I want you now to try out number 21. All the rest I'm going to let you do on your own. But try out number 21. So pause the video and then unpause to work this one out together. All right. So hopefully you did do it and you just didn't keep letting my video play. So here's what you should have done. You exchanged your x's for your y's. I am having to solve for my y, which is right here, but it has too much company, okay? We need to get rid of those numbers. So in order to get rid of those numbers, we've got to undo. We're going to undo the 5 first. It is dividing by 5, so I'm going to multiply both sides by 5 so that I can cancel out 5 divided by 5 because it's a 1. 5 times x is 5x, and the y plus the 11 comes down. One more step. I need to subtract 11 on both sides. Wow, that was really bad. And I'm going to erase it. I was going to tell you, you know what? I'm going to let it go, but I'm not going to let it go because it bothers me. I know. I got issues. Here we go. Negative 5x. Nope. 5x comes down. 5x minus 11 equals y, because those two add to be 0. So now that my y is isolated, I can say, hey, I found my inverse of the f of x function that you started out with, and that answer is 5x minus 11. And you're done. So, lastly, we've got one more thing for you to cover and understand. So what if I gave you two functions that I believe are inverses of one another, and I need you to verify, I need you to prove to me that they truly are inverse functions of one another? What will you do? All right, so here's what you're going to do. First of all, I need you to copy down this. Okay, so sometimes we are able to prove functions are inverses of one another by doing the following, okay? So, proving functions are inverses of each other can be done algebraically using composition. So we're going to use a technique that we learned in 2.2 to help us prove that these two functions that I'm giving you, f of x equals negative 4x plus 8 and g of x equals negative 1/4 x plus 2, to prove to yourself that they are truly inverses. Now what some students are going to want to do is say, well, Ms. Hanlon, can I just switch the x and y and do all my solving process like you just taught me and see if it matches this one? You totally can do that. It is a way of proving the functions are inverses, but notice I said using composition. So I am tying your hands in this case because I want you to use composition. As a matter of fact, half of your homework today that I'm going to assign requires you to do this very thing. So this problem is going to help you do the last 6 problems of your homework. So here's what we're going to try and do. We need to verify that these are inverses. So keep taking notes here. I need you to show me that if you compose both of these functions, that both of them are going to end up equaling x. And I need you to compose them in both directions. So I need you to do f composition g and g composition f. And both of the answers, when you fully simplify, have to end up being x. Why? Because inverse functions are a result of the original function being reflected over the y equals x line. That's why the compositions have to both equal x. So let's start doing that. Okay, so I'm going to hold this paper here. So I actually have the answer right underneath there. So let us start off with f composition g. So f composition g is dependent on us working with these two problems. So let's do this one first. Let's rewrite it in function notation. So f composition g of x is going to be f of g of x. And as we learned in section 2.2, we start from the inside and we work our way out. So we're going to take that g of x and substitute it into the f function. So let's find our g function because we don't have an x to plug in. So our g function is this one right here, negative 1/4 x plus 2. So instead of plugging in a number, we're plugging in an expression. And so what I need to do is I have to take this whole thing and I need to go to my f function and I need to put all that stuff into my f function. This is my f function. And what you're doing is, notice this here replaced this x. Okay, instead of f of x, I wrote f of blah. So that means if I replaced this x with blah, That means I need to replace this x with blah. So let's do that. -4, open parentheses, I'm getting rid of this x and I'm replacing it with -1/4 x plus 2, and then I have a plus 8 plus 8. Now I'm going to simplify, distribute, that becomes an x, distribute, that becomes a -8, and the positive 8 comes down. Simplify, yay! I'm happy because I got an x so far for the first composition. I am going to hopefully get an x again because that's what I need to prove. If I don't get an x, that means you did something wrong algebraically. So just go and find out if you forgot to distribute a negative or something, okay? G of f of x, this time my focus is on f of x being substituted into g, right? So I'm going to make a notation here. F goes into my g function. So let's identify what the purple function is. It is -4x plus 8. So this purple stuff needs to go into my g function. So we can do it again. Here's my g function. This x was replaced with this stuff. Therefore, this x needs to be replaced with this stuff too. So equals -1/4. That x is being replaced by -4x plus 8 plus 2. Distribute. That becomes a positive x. That becomes a -2 because 8 divided by -4 is -2. The positive 2 comes down, and yay, I'm a happy camper. Yes, F and G, you can't see what I'm writing, are inverses of one another. Okay, that's it, folks. You'll have 6 of these problems to do on the second half of your homework. So go to Google Classroom. Please make sure to read the details of your directions to get this done. Okay?